And so we carry on with our discussion on the centripetal force. As this object goes around the circle, and I'm not saying what it is, but it's just going around the circle, so obviously there is some force that's needed to be keeping it in the center. And so as this object goes around, we see that this object, and this is really important that you understand that even though this object is moving at constant speed, it is accelerating. And you say, well, wait a second, it's not getting faster or slower. Yes, I know, but it is changing direction. Remember, acceleration is a vector. It has magnitude, which is size, and direction. And so although this guy is remaining constant and he's not changing, he is. So you're changing a certain part of the vector, so that is acceleration because you are changing the velocity of the object. You are changing the way it's pointing, although you're not changing its size. And so again, wherever there's a force, there's acceleration. Remember Newton's law, F net equals ma. Well, I'm assuming the only net force acting on this guy is, imagine I'm doing this in space if you wish, there's no gravity, or it's going on a table, or it's a car. So if a car is going around in a circle, if I look at the free body diagram, I would have the normal force this way, gravity this way, and the centripetal force this way while this object goes around. And of course, that centripetal force is the same as the force of friction. That's what's supplying it as the car goes around like this. That vector, which is pointing like this, will go around and keep pointing towards the center as it spins around. Right now, the center of the track is there, and he's kind of going like this. He's going to whip around and come like that, okay? So then we obviously cancel all these forces, and friction would be the only force. So let's, so it's a car going around the track, it would be that as well. So while it's doing that, we know that where there's a force, there's an acceleration. And so we have that the centripetal force creates a centripetal acceleration. We use the letter A sub c, and without deriving this formula for you, I'm going to say it's going to be the square of the velocity divided by the radius. And that is your equation to find the centripetal acceleration. So this is the acceleration that the object feels as he goes around in a circle. And this acceleration is very real. Have you ever gone around in a circle in a car and felt the force that you feel when you are making a turn? Well, that is, your car is basically turning towards the center. You want to keep going in a straight line, and so you basically have a reaction force happening on you, but you feel that force. For now, I'm just going to leave it to that without going into the centrifugal force, which is a different topic for now. And it's a fictitious force. But you feel that force when you make that turn. So there's a real acceleration happening there. In fact, when they want to have astronauts practice for high G's, they make them spin around really, really fast in this chamber, and the acceleration here starts to go into several G's. The centripetal acceleration, which simulates the acceleration that they would have to deal with at outer space. And so here's a simple formula for finding the centripetal acceleration. Remember, we had a formula for finding the speed, which was 2 pi r over t. So they don't give you the speed, you need to find it there, and then plug it in here to find the centripetal acceleration. Once you find the centripetal acceleration, you see it's pretty easy to find how much that centripetal force is. So look, what this is doing is it's giving you the amount of centripetal force needed to make something spin around at a certain speed with a certain radius. And so your centripetal force would just be the mass of this object times your centripetal acceleration. Centripetal acceleration will also be in meters per second squared, like centripetal acceleration, or acceleration should be. And the centripetal force will be in newtons, just like it should be. And if you think about it, when I do make this calculation, say if I have a certain speed that we put in for the car, and we do this and find the centripetal force, you can see that it's telling you how much frictional force the car is going to need to go in the center, or how much tension your string is going to need to keep it spinning in the center. And you can predict what that tension is going to be, or what that friction force is going to be, or what that normal force is going to be, whatever is needed to give you that acceleration. Okay? So next class we'll actually do some practice problems where we can actually use these and figure out the centripetal acceleration and the centripetal force. Just keep in mind, centripetal force is not a new force. It's different guys who step up and say, hey, I'm going to be the centripetal force because, that's what we're doing in an experiment. Okay? I'll talk to you later. Bye for now.